introduction. Thank you very much. And welcome all participants to today's session. So today, as ma'am told, we will be doing the introduction to MLOps. So yesterday we had interacted, if you remember. I just briefly told you about what MLOps is and why we need MLOps. If you remember that cakes I told you. So you may be having a few idea, and yesterday I also told you the tools that we are going to use today, and I told you just to explore the tools that I discussed yesterday, right? So my plan will be to introduce the MLOps. So before that, before giving you any introduction, I would like to know the pulse of the crowd. Like I would like to know the exposure or the familiarity of the participants in these areas, so that I can curate or I can tailor my lecture in that way. Even the hands-on experience also I can tailor in such a way that it will be more fruitful to you. Now I will be presenting, first of all, I will be presenting a small survey, a short one. So please fill that survey first, and then we will start exploring MLOps together. Okay. So let me share my screen. Okay, so you can just log in using the QR code and answer this question. So I hope it is visible for all of you. Either you can scan this QR code on the screen, or you can just do, you can join slido.com, take slido.com and type this code shown below. And please just answer these questions. The code is 4256456. So I hope it is visible for all of you. If it is not, please let me know. Okay, I'm getting answers. So rating from 1 to 5, 1 being a very beginner or novice, and 5 being an expert. How familiar you are with MLOps concept? So I got only 19 responses. I expect at least 100 responses because we are a crowd more than 100 people, right? Yes. So okay, nearly 100. Okay, at least 50 responses should be there. Okay, so my first question was, how familiar you are all with MLOps concept? One being a beginner or novice, 2, 5 being an expert in it. Okay, got 40 responses. I will go to the next question once I get at least 50 responses. Because at least 50% of the crowd, I understand, 50% of the crowd, that will be good for my teaching as well. Yes, okay, for 50. So from this score I get, I understand nearly 70% of you are new to this concept, MLOps concept. So that means I need to extensively explain the concept with you. What is MLOps and what is the need of MLOps? So yesterday I gave you a brief introduction. I will be explaining further. Right. So my next question is, how familiar you are with building ML models? So if you have built ML models at least once, or you have seen ML models, again, ranging from 1 to 5, 1 being a novice who have never seen an ML model, till 5 who has built multiple ML models or are still working with ML models. So you can just rate yourself 1 to 5. 1, a pure beginner who is not at all familiar with an ML model, and 5 being a person who can confidently create multiple ML models. Okay, so easily I got nearly 54 responses, and I see an improved result where most of you are familiar with ML models. Only 30, less than 35% people are not familiar with ML models. So most of you know what ML model is. So again, for the sake of this 31%, I will just brief maybe 5 minutes on what ML models are and how we use them. Good. And my next question, how would you rate your JIT knowledge? Have you worked with GitHub? So should I start from the very beginning? So here again, 1 to 4, 1 novice, 1, so that should be 1 novice, 2 beginner, intermediate, expert, like that. So again, I'm getting few answers. And it is more than 50, I will stop this. So yes, again, I see a similar trend here also. More people are novice or beginner, so they haven't used it. Novice in the sense they have not used it at least once, and we do have some intermediate users as well as experts in this. Okay, so clearly the trend is towards the beginner stage. So today I will be sharing. I will be discussing MLOps in keeping in mind that most of the participants are at the beginner stage or those who are learning or trying to learn MLOps and machine learning. So let me just begin with telling you what is MLOps and what basically, first of all, what is machine learning, and then we will move on to MLOps. Okay, so let me share my screen once more. Okay, so I hope my screen is visible for all of you. So in between, if you have any question, you may just stop me in between and ask. So you can ask anytime. You can use your chat to ask any question. Or if I'm sharing the screen, if I'm not seeing the chat, you can even interrupt me in between and ask the question. Okay. So let's start with machine learning. So what is machine? So yesterday, Achut sir gave us a very great introduction or a very good introduction. He told we should consider machine as a baby, and that is one of the examples we all tell students when we train them on machine learning, because you should consider the system as a baby, machine as a baby. So the initial days when machine was considered an adult, as I'm just taking his words, he said initially machine were considered as adult, and usually what happened is to machine we gave the data as well as we passed in the logic. And for example, if I want to add two numbers, I passed a and b, and I passed the logic a plus b, then I got the output, let's say c equal to a plus b, and it gave me the output, which is c. Right. This was the traditional approach to programming a computer, and it was very fast. We were able to compute many things fastly. But with the introduction of machine learning, the traditional method changed in a way that into the machine, what we pass is we pass both data as well as the output that we need. For example, if you're going to build a camera which recognize whether you are putting on the helmet or whether you are putting the seat belt, The data will be multiple images which contains images of people with helmet and without helmet. And the output we expect is it to label that this particular image is with helmet or without helmet. And the output that we, so this is the output. So we give images, we label the images, we say those images, these are the images, red images are those without helmet. Okay, so this is without helmet, we give proper labels like this. And the output that we expect is the logic, or a way in which the machine can identify these images. When I give a new test case, the machine should be able to identify whether it has helmet or not. Okay, so this is basically the basic workflow in which a machine learning model works. Right. So this is basically a machine learning, a basic, very generic way of describing a machine learning project. So we will have few things. We pass on the output that I specified earlier. We call it the label. So basically, if it is a supervised learning algorithm, so I'm not going into supervised or unsupervised or more intrinsic details or the basic details of machine learning. But here I am assuming, let's say we are working with supervised learning. So we provide a labeled data. Okay, so labeled data may be like this. There will be some images of apples and oranges. So here it will be labeled. The label will be, this is apple and this is orange. So this is called a labeled data. That may be images, that may be text data, that may be audio data, or that may be video. This may be NLP, natural language processing. So this may be text, anything, any data which is labeled, which is provided into a machine learning, which learns from it, and it should be able to identify any test data given to it. So this is the basic concept of a machine learning algorithm. Okay. So why do we need machine learning MLOps? Yesterday I told you one example where I talked about a person making cake, a person who got a idea of making a recipe of cake from internet, and he tried out the cake and it came out very well and he enjoyed it very much. But next time he wanted to try it, and with most of us it happens often, right? We try a recipe, it comes out very good and we are very confident about that recipe. But next time when we try that, maybe the family says, or maybe our friend says, no, it doesn't taste as good as the time you made it first. Right? This all happens. Why? What is the reason? Yesterday also we discussed this. The reason being, typically the reason being, we didn't follow a method or a procedure, right? We didn't follow any procedure here, or we didn't follow the recipe as it was as needed, or we didn't know how to approach it the next time, right? So let me just. Sorry. Okay, so the main thing with main thing is we need to know how to work with the recipe again. So what we need is, we need to understand why we got that output. Okay, so in MLOps, basically the thing is we need to follow a process. So what is the process that we need to follow? So when we come to MLOps, so usually what happens, people build this machine learning model and they are very happy with that model. So I'm very happy with that model, but I do not know how to reproduce it when it comes to production, or I want to produce it in a bulk. When it go to production, I don't know how to make it, or how to scale it. I want to make multiple copies of it. I don't know how to do that, or I don't know how, if what happens after some time is this data may change. There may be a data drift. For example, I told about AI cameras. In AI cameras, the data drift is not very common because people the images doesn't change that much. But think about a bank data. Think about a data of a transaction being fraud or not. So I have a data containing a set of transactions. Say I have the date, I have a transaction ID, I have the type of transaction, I have the type of card used for the transaction, if it is credit card, debit card, like that. I have the time of transaction and say amount. So I have all these data. So there will be some date, transaction ID, type of card, time of transaction, the amount, and these are my features. These I call my features. And I have an output that will be predicted. These are my features, and the output is called the target. So the target here will be whether the transaction is fraud or not. So this transaction being a legitimate transaction, I am telling it is not fraud. The answer, the label is 0. It is not fraud. And the next transaction, I have some date, transaction ID, type, transaction card, type of card, time, amount, but this is a fraudulent transaction. So I give a label 1. Like that, I have many data. Okay. And using this data, so suppose this data is stored, this is stored, so this data is stored, it is used to train a machine learning model, and the model works very good, and but what happens is over the years, the fraudsters change, the way in which people do fraudulent transactions change. There may be drift in the data. This may not be the pattern. All those things can be seen in the data. So this process of changing the data change, that is called data drift. So there may be a drift in the data, right? So there may be data drift. The data may change. So what happens when the data drift? I need to update the new data or change the existing data. I need to add new transactions, new fraudulent transactions may have appeared. So I added this new data. Now I need to retrain the model again so that the model understands this pattern also, right? And again I need to deploy the model. Then only this will work for every aspects, or every time it will work better. Otherwise, after some time, our model deteriorates, it degrades, and it doesn't give a good result, and my customer will not be happy, right? So in that case, I need to, when data drift occur, I need to add new data, and I need to retrain them again so that people will be using it and they will be getting better results, right? So how weather prediction was done earlier. We get answers like there is a chance for there is equal chance for rain or not not getting enough rain. So we used to get predictions like that, but nowadays you can see the weather predictions are getting much better and better. The reason being the weather is changing. You cannot work with the old data. We cannot work with data from 80s, right? We have legacy data, we have the old data, but the weather condition today doesn't depend mostly on the weather we got in 80s. We need updation in that data. We need data. We need to train our models using the data from last 10 years. So the data drift occurs there. So we need to retrain the model. For all these things, we need to keep track of the code data. So it's not like once you build the model, it's not simple as build the model, test it, deploy it, and just forget it. No, you cannot do that. But rather, this is a cycle where you build it, test it, or you can say train the model, then test the model, deploy the model, Now there may be data drift happening again. So you need to continue this process. To continue this process, we need to keep track of one, the code as well as the data. Right? So today we will be seeing how to keep track of this code and data. So we will be keeping track of the code using GitHub, and we will be trying to keep track of the data using DVC, data version control. Okay, so this is the one part of today's agenda, how to keep track of our code and data so that we can always continue this process in the production, and we will always have a ready made model with us, which is up to date, which is retrained. Even though data drift has happened, it is retrained and deployed again to adapt to today's situation. Right. So now that is one part which we will see today. Another part. So as I told, since we do have new beginners, machine learning beginners, so I just told somehow we are going to train. I'm giving input and I'm giving output. The machine is learning. So how does the machine learn? So there are various methods in which machine learn. So we talked about unsupervised supervised learning, where we have data and corresponding labels. So we do have various algorithms in supervised learning, starting from SVM, or we have decision trees, random forest, or if we are going to predict a number here, we have regression and classification, and we have linear regression, algorithms like that. Okay, so these algorithms,
തിന്നാൻ പറ്റൂലല്ലോ ചേച്ചാ, അവിടെ വെളിയിൽ വെച്ചിട്ട് കുറെ കൈ എടുത്താ പോരായിരുന്നോ?
okay, so these algorithms help us in learning. In this machine learning process, these algorithms help us. So these algorithms have some parameters. For example, the decision random forest model, this is, you can see, this is decision tree and random forest. So from the name itself, you can understand random forest consists of lots of decision trees. You can just say how many trees you need for training, n estimators. So I'm saying I need 100 trees in training. So the result I get when I train with 100 trees is different from when I train. Sorry, when I train with 200 trees. So there will be a drastic change in the results. So how do we understand the result? How do we find out the result? So we have various metrics. We have various metrics in machine learning to measure the goodness of our model. So we can check the accuracy, precision, recall, F1 score, etc. Or in case of linear regression, if we are predicting a number, we can check RMSE values, mean squared error values, or R squared value, like that. Okay, so again, these are some of the metrics, like marks, like we give marks for the students, like that we are giving some mark for that model. So I build a particular model. So what machine learning engineers do is, using some of these algorithm, let's say any of this algorithm, I build a model. Okay, so I build a model M1, which have been configured with a set of parameters. Okay, next I build another model M2, set with another set of parameters, a third model M3. Mind you that all these models are built using the same label dataset. I'm building various versions. I can consider this M1 is version, M2 is a version, and M3 is a version. Here I say my accuracy is 98%, and in second model with the same data, I get accuracy of 98.9%. And in third model, I get accuracy of 99%. Okay. So clearly, in terms of accuracy, I'm not telling accuracy is the right metric. It also depends on what problem you are trying to do, what problem you are trying to solve. Sometimes accuracy may be better, sometimes recall may be better, sometimes F1 score may be better. It all depends on what you are trying to solve anyway. If I am considering the accuracy as my measure, you can see this is the best model I can obtain, right? So yesterday, if you remember, I showed you an image where a person developed a model and he got a good model, but he was not able to reproduce it. Not able to reproduce. Why? Because the parameters changed. Like in case of the cake example, the parameters may have changed. So this person may have used number of trees as 100, but he haven't recorded it anywhere. The parameters value has not been recorded anywhere. Here, suppose the number of trees is 50, and here it was 200. And this was the model that worked better. So this is not only a single parameter, but various parameters affecting the accuracy of a model or the metric, the goodness of a model. So that may be the reason. So how to reproduce it? We need to record. So in scientific experiments, I know there are so much research scholars in here. Each and every experiment you track. Like first time when I did the experiment, I used so and so and so, and I got this result. Second time I used so and so, and I got this result. Like that, we track the experiment so that we will be able to consider third time I used this and this, and I got a better result. And now I can understand from this track, I can understand which is the better model I created, which is the best experiment. And I know the parameters I used in that experiment as well. This is called model tracking or experiment tracking. And that in our case, we will be doing that using a technique, a library called MLflow. So this is today's agenda. These are the things that we are going to discuss today. So this is the theory part I wanted to tell you before going into the class. So I would like to stop here for a minute so that I can take questions here. If you have any questions, because now since we are going to start our hands-on part, I want to make sure that you are all clear with the concepts which I told, even the beginners. If you have any doubt, please don't hesitate to ask. Please ask, and I will be happy to answer. So I'll give you 2 minutes. If you have any question here, you can ask me. Any question regarding what all things that we discussed till now? Regarding what all things we are going to see today, and those people who said they are not familiar with machine learning, I just gave a brief intro. I hope it is clear for all of you. If you have any question, anything you want to discuss on what I told till here, please feel free to ask.
Hello.
Yes.
Yes, ma'am. Ma'am, you told that whenever there is a data drift, so we need to keep track of code and data by using GitHub and DVC.
Yes, that is one method. Okay.
And second, you mentioned that if we are having 3 models, and for example, M3 is giving 99% of accuracy. In that case, for tracking the model, we have to use MLflow library.
Tracking, yes, that is during the experiment. Yes.
During the experiment. Now, for example, if M3 is a model, in the M3 model, if we are using different data, so for that data, it may give different kind of accuracy.
No, can you come again? I didn't get. I told you in M1, M2, and M3, I am using the same data.
Right. For same data, suppose for example, 99% is accuracy.
Okay, fine.
And if you take another data with some noise or some different values, so that value will get changed, accuracy will get changed.
Yes, sure, it will get changed.
So in that case, we have to keep track of data drift also as well as model tracking also?
No, actually, this model tracking is done during the time of experiment. Okay. So at time of, usually what happens, we do an experiment, we try, we give the data, we experiment with different models with various parameters, and then before deploying, we fix on a model. We fix a model. Okay. So before going into production, I will fix, okay, I don't know if I'm sharing the screen. I'm sharing the screen, right? So I'm fixing that M3 is going to production. So what will I do? I will create M3.pickle. So pickle is a file that create the model, and I will be deploying this model alone. Then this model is being deployed. So now this is in this phase. I finalized. So that is, it is in this phase, deploy phase. Now what happens if there is data drift? So I finalized, I experimented with M1, M2, M3, and I decided M3 is the best model, and I deployed it. Suppose, as you told, after some time, some noise comes in the data or there is data drift. What I will do is I will again build the model, retrain the model. At that time also, when I am retraining, I will have various versions of models like M1, M2, M3. From that, I will choose which one is the better model, and I will test it and deploy it again. Does that answer your question?
Yes, means all the time, means all these three are the iterative processes. Means code, data, as well as this model tracking also.
Model tracking is a one-time process before deploying. Once you deploy the model, once there is no change in data, you can keep on that model for maybe, in some cases, maybe months, in some cases, maybe years. For example, let's take the example of AI camera. So in case of AI camera, after training, the images doesn't change that much because people with helmet and people without helmet may look alike, look like that only. But the quality of images may be different. So after sometimes the police department feels the machine learning algorithm is deteriorating, they can just feed it with a new data with maybe images with more quality. And at that time, we again retrain the model and find out which is the best model. And that best model will be deployed. So to find the best model, we need this experiment tracking. And after deploying the model, we are monitoring the performance of the model by using data drift. So you will see in upcoming classes how it is monitored. And once there is a data drift, we need to keep track of the old data. We need to understand what is the old data. To keep track of that, to version that, we use GitHub and Deepasree. So these are two different processes. One during the experiment phase, and another during the after the deployment phase. So two aspects in MLOps.
Okay.
So since we had some participants who are not familiar with ML concept, I told the other way around because I wanted to tell what is data and what is the target. That's why I told about this. But in real MLOps pipeline, the initial thing that happens is this process where we find the best model, then we deploy it, and then after that only we do this version control. Okay, so let me just clear that. So initially, at time of training, so training and testing, to keep track of experiment tracking, we use MLflow. And finally, using this, we find the best model, and then that model get deployed. So once it is deployed, now we have finalized the code and data that will be pushed, that version will be pushed to Git and Deepasree. And again, in the next cycle, maybe after a few years, when this machine learning model is not working properly, we need to repeat this iteratively. At that time, again, we can use MLflow to experiment tracking, and we can get the versions of our code and data from Git and Deepasree. Okay, clear? So any other question?
Okay, madam, actually accuracy is a parameter to judge whether that particular model, otherwise to compare multiple models, right? Accuracy is a parameter to compare the performance of different ML models, right?
Yes, one of the parameters. It is
One of
not
the parameter,
one
okay.
of the parameters. As
So
I told that,
yeah,
yes.
but then what is the actual purpose of this ML flow, otherwise ML tracking? That is again finding out which is the best model among various models, right?
Yes, yes. I know even researchers then do not rely on MLflow to understand which is the best model. They just repeat their experiments and find out which is the best model. Okay. But here MLflow is like a tracking tool where I am doing 100 experiments a day. I cannot keep track of every parameters and what is the corresponding accuracy I got. Or I want to automate this. I want my machine learning model to automatically try all the possible parameters and give me the accuracy. So in that case, we can use MLflow. If you're familiar with grid search CV, there is an algorithm called grid search CV, which do the same thing. It will give all the parameters to machine learning model, all possible parameters to machine learning model, find out different versions of the model and give you the best model. But it doesn't keep track of it. After a few days, if you want to see that, you have to rerun it. But MLflow is a method in which it will be there. You can see it as a UI, you can see it as visualization, where you can compare both the models. That is the advantage of MLflow.
Okay.
So it is just for tracking the experiments. In real scenario, when there are multiple experiments to be tracked, we need not manually go and give different parameters. We can just automate it, and later on, maybe after few hours, we can come and see and compare the various models created with different parameters. That's the idea of MLflow. Yeah. So I hope it's clear. If you have any more question, you can just use the chat. I think I will move on to the hands-on part. So initially, I would like all of you to create a folder inside any. So let me stop presenting this. So you can just create a folder anywhere in your system. You can name it anything you like. So you can see here, I have created a folder named UOKFDP. You can also create a folder. Okay, so here I want to open my VS Code from this folder, so that I am typing CMD, the command prompt. And from there, using code space dot, I'm opening VS Code. So this is my VS Code. Here I have a folder named UOKFDP. So where I am going to create all the necessary files. So first I will be showing you how to do MLflow tracking, and then we will see how to push this to JIT and DVC. So all of you please follow this. If you have any questions how to take this, please don't hesitate to ask.
Excuse me, ma'am.
Yes.
Ma'am, can you please repeat the steps once more?
Sure. So first of all, create a folder. Okay, create a folder anywhere in your system. So I have created a folder. And here, to open the command prompt, or you can just open the command prompt and type this address. Take this address. Basically, what I'm doing is from command prompt, I want to take this address, but for easily to take it easily, I just type CMD here, indicating command prompt. In the address bar, from the place where you want it to open in command bar, just type CMD, and it will open the command prompt for you. So you can see the command prompt getting opened. So you can see here, you can see the address inside the folder which I created. Or you can just open command prompt and using CD, you can just do the same thing. You can just copy this and it will open it for you in the same location. Okay. And from here, I just typed code.space, indicating I need to open VS Code in this location. I want to open Visual Studio Code with this folder. Again, this is just one method. If other method is, you can open Visual Code and open the folder to this, giving this path. So code space dot, put enter. You can see Visual Studio being opened in that location. Okay. So now I will share a Collab notebook with you in which I have written today's code. So you can just use that. So I'll put it in chat. So you can open this Collab notebook and you can copy the first set of code in it. It says train.py. So I'll just show you. Okay, this is the Collab notebook that I shared. Just copy the first cell, train.py. You can just copy the first cell. Copy it and bring it to the VS Code. Here you can create a new file named train.py. paste it. Okay, in my case, autosave is enabled. You can just check. In your case, if autosave is not enabled, just enable it so that it will be saved always. It should be a tick. This autosave should be a tick mark. In that case, it says it is enabled. That is, whatever you type here, it will be autosave. So this is just a small code. So those who are familiar with machine learning will easily understand this code. For those who are not that familiar, I'll just explain. This is a code. Once everybody is doing this, just please listen here what this code does. So this is a code where I'm taking a small data set called Iris. Iris is a very popular data set among machine learning learners. So Iris is a data set which contains, let me just show you Iris so that you will understand.
Hello, experiment.
So let me just show you Iris. So this is the Iris data. So for those who are not familiar, so this is the data regarding a flower. Okay, Iris is a kind of orchid, a kind of flower. So this data is related to a flower. So for this flower, we know, or we have like nearly 144 entries here, 143 entries here. That is 143 samples of flowers, where we know the sepal length, sepal width, petal length, and petal width. And according to this, we want to understand whether this is which species of Iris it is. Using sepal length, sepal width, petal length, and petal width, it says that gives the classification whether it is Iris setosa or versicolor or virginica, like that. Okay, three types: versicolor, virginica, and setosa. So I'm going to train a machine learning model with this Iris data, and using which it will learn when I give a new data about sepal length, sepal width, petal length, and petal width. It should be able to classify it whether it is Iris setosa, Iris versicolor, or Iris virginica. Okay, so this is the data I am trying to train the model with. So this is a very simple data. So to keep it simple, I have chosen this data. So you can see here. So I load the dataset Iris. So it is present in a library called sklearn, and I imported all the necessary libraries. And I'm just converting it into data frame. Now I am saving this so that I can use I can save this data set for DVC later. I want to do the data version control. Therefore, I am saving this. And I am defining what are my features. As I told earlier, everything other than the target, all those are considered as species. So the species is the target column, which I consider as Y, and X contain all other columns other than target. And now I do the train test split part. I use 80% of the data for training and 20% of the data for testing. And I am using the logistic regression algorithm. So if you remember, this is the logistic regression algorithm I told you earlier. I told you we use various algorithms, any of this algorithm for machine learning. So here I am using logistic regression algorithm, and I am giving a parameter. I'm just using a single parameter here for simplicity. So this is the max iteration parameter I'm using, and initially I am setting it to 200. So according to when I change this parameter, the metrics in which I am going to evaluate it may also change, right? So I just fit the model and I just store the model as model.pickle. So here I am not adding any, I haven't added any model MLflow part, anything. I'm just training the model. For the sake of understanding a simple machine learning model, I'm just saving this. Okay, so let me just run this, take the terminal, and to run this, I'll just type Python train.py. So it will take some time. So my model was trained successfully. So before running this, maybe in your case, in my case, all these libraries are installed. So if in your case, if they are not installed, we can just add a requirements file. So here I'll just add a requirements.txt. So that is a requirements file. So here inside this requirement.txt, I will add few things. I will just add the things which I want to install before running this, because if you are running this for the first time and if the libraries are not present there, so you may need to install those. So I'll put in the chat what all things you need to put in requirements.txt. Okay, those things are there in chat. So I need to install Pandas, scikit-learn, MLflow, because I'm going to use MLflow. Joblib is to save the model. Flask I'm using, I'm going to use a Flask model to show you how a front end look like. And if time allows, I will show you how we can have a HTML file and how we are going. So DVC also, because I'm going to use data version control also here. So these are the things which I need prior to doing this. So I'll just do pip install in terminal, pip install -r, because I'm going to get it from a requirement.txt file. So I'll just tell to install. So it will be installing all these things. Okay. So it is, you can just type this pip install -r requirement.txt. Will install all the necessary libraries. These are the libraries. I have specified the libraries. It will install all the necessary libraries. And after installing, you can just okay, done. So our next, so let's just build a Flask model. So in the same file, you will, in the collab file I shared with you, you can see in the next cell there is a file name called app.py, which I gave the heading as app.py. You can just create a new file called app.py, so which is the front end file, which is the Flask file which hosts this. So here also you can see it is a Flask If you're not familiar with this, we are loading the model.pickle that we just created. The species, we are just defining, we are just mapping it to numbers, and we will call an HTML page so that it will be rendered. So we need an HTML page as well, right? Then only we will be able to see this, the front end. So to create HTML page, we need to create a folder here. So just create a folder here, which I will be naming it as templates, because in Flask, this framework is necessary, and inside which we will create a file called index.html. So you can see in our collab file, index.html is given next. You can just copy that as well. So paste it there. So index.html is also pasted. And if you want styling, with this itself, it will work. If you want styling, we can add a CSS file as well. So let me just run this again. So to run this, once you have done this much, you can run it using Python app.py. Okay, so let us just click here. Okay, so you may see a page like this. A page like this, iris classifier, where you can give some sepal length, sepal width, petal length, petal width, and you can predict, it says it's set. Okay, so I'll give you 5 minutes just to complete this experiment. If you have any questions, please ask me.
Hello, ma'am.
Yes.
Can you explain what you did after making a file, making a folder in a short?
Templates folder.
Yeah. After making the folder, ma'am has shared something, collab file or something. My network was some small issue. That's why I
The
didn't get
initial folder.
in a short.
Are you familiar with Flask? Have you worked with that?
Django, I know, ma'am, but Flask,
So it's similar. It's similar. Okay. So I'll just explain. You just create a folder, and I have shared a collab file. Okay. Inside which I have shared in each cell, there are 3. In first cell, there is train.py. This file. You can just copy the content from that cell and paste it here. The next cell contain app.py, again a code for deploying it using Flask. And like in Django, also in Flask, also we have few frameworks to be followed. It's like few template, few things to be followed. So we need to keep all our HTML files in a folder named templates. So I just in the third cell of the collab file, I have an HTML file so that you can copy and paste it here. You can create a folder named templates, and inside that you can create HTML file. This is what I did.
So
okay.
It's like a MVC kind of, right?
Yes, it is an MVC. Yes, because thing I wanted to do is to create an application first, so that then we can track that with various machine learning models.
Okay, ma'am. Which some library also, ma'am, you installed, right?
Yes. So the requirement.txt. So this I put it in chat. If you want, you can I'll just copy it once more for you.
Okay.
So this is just put it in a file called requirement.txt and
Okay.
just install it. Pip install -r requirement.txt. Then every library will be installed.
Okay, ma'am. Thank you.
Okay, fine. So I'm just adding for beautification, I am adding CSS. It is not really necessary. So for those who are really want that, can add a style.css. So this is just optional. Okay, it's not necessary. Without which it will not run, nothing like that. You can just copy the CSS file just so that my page will look beautiful. Okay, so let me show you how the page looks now. So after entering the CSS, it looks much better. So I can just add this, and predict. Again, it says settings. Right. So I haven't checked the accuracy. This is how an application look like. I wanted to show you how whole application look like with Flask, or we can do it with Fast API or Django. You can just choose that. So anyway, I just wanted you to get a feel how a machine learning application will look like. So especially for those who are not that familiar with machine learning, now I am just predicting whether a flower, giving it sepal length, sepal width, and petal width. I'm just predicting. So now you can see the prediction change to original. So by just giving the sepal length, sepal width, and petal width, I'm just predicting what species of iris flower it is. Okay.
Excuse me, ma'am.
Yes.
Ma'am, how this application is communicating with our classic model?
Model. Okay. Just a minute. So here you can see I created a model. If you remember, we run this first, right? We run this file first, train.py, Python train.py, and this model was saved as model.picker. Okay, this model I saved it as model.picker. Okay, now in this app.py, I am just loading that pickle model, and here I am reading sepal length, sepal width, petal length, petal width, and I am just passing it to the model to predict which is the prediction, which is the flower. So here it is communicating to the model. Got it? So this is like the basic things which I wanted to share so that you can get a feeling how an application, a front end and back end of a machine learning model look like. Now, if I want to, so this may not be my best model. Okay, this may not be my best model. That is what I wanted to tell you. I created this model with this. I didn't check for the accuracy or anything. So here I am going to add a few set of code. Okay, so I'll just give you line by line code. I'll just put in the shared collab. So first I want to import MLflow. So here I am going to import MLflow because I am going to track this model, right? Now I want to add just a line of code here. So the place where I'm going to fit the model, I'll just say with MLflow dot start run. And here I will indent these two lines because I want these two lines to be indented. Maybe I will just copy everything and put it in collab file. So modified version, I will put it in the collab file. So you can see they're modified. You can just copy everything. Now what I'm going to do is I'm going to run it. So now I added the MLflow part also to this, and I'm going to run this. So again, since I made changes in train.py, I'll just run Python train.py. So it will take some time as MLflow is also there.
Ma'am, I have a doubt.
Yes.
Ma'am, after executing this Python train.py, this model.pkl file again recreated or
Yes,
some update will happen?
yes, it will be created. Whenever we run Python train.py, this model.pkl will be updated.
Okay, okay.
Excuse me, madam.
Yes.
Miss, you kept, madam, two lines inside that start and MLflow start.
Yes.
First one is a building model and second one is fitting model.
Yeah.
So whenever we create a model and whenever we create that model, so these two lines must be in the MLflow.
These two lines should be inside MLflow so that we can log, we can see what the experiment. To see the experiment, we need to write these inside MLflow.
So this,
Then only we can flag that.
This is applicable for CNN models also, no?
Any model, yes, it is applicable to any model.
Okay.
Okay, so now we need to add few things. So I'll just copy those things in the, and I'll explain that for you. So I'll just add it in the collab file as a new file. Just add those. You can just change the whole code and add it. So instead of this, you can add that. So I'll give you the complete code. Okay, just give me a second. I'll just paste the complete code there. Then you can take that. Okay, just take the complete code from there. It's the same. The only difference is I am just logging everything, logging each and everything. So rather than earlier, we just trained using that, right? Now I'm just logging using everything. So here I'm just telling test size. If I want, I can just change the test size and try. So with this test size, with this random state as 42, I'm just logging all these parameters. Maximum iteration, I set it as 200 earlier. So here you can see the maximum iteration is 200. And then I'm just finding the accuracy score. I'm just logging that as well. Then I'm just dumping that model to model.pkl, and I'm storing this model.pkl as an artifact of this particular run as well. And also this particular data also I'm storing it as an artifact. Okay, so I'll just run once more. I'll just show you what is the difference when I run this again. So you can see here, all these things will be logged. Okay, and you can see a new folder. After you run this, you can see a new folder appeared here with the first run 0. Okay, it says 0, and inside which you can see there is a version and a set of artifacts. If you want to see it fully, you can just click like this. You can see the artifacts in here. It has saved the data it used in this current run, and also the model.pkl it has used. So I'll do one thing. You can just see what I'm doing and then you can do. So maximum iteration, I'm just changing to 300. So maximum iteration 300. I just changed it and I'm just running this again. So you can see a new run will occur here. You can see a new entry getting here with new model.pickle and new iris.csv getting saved here. So basically what I'm doing is every time I run this, even I can change the iteration value, I can change the test size, I can change all the parameters used for this building this machine learning model. And I'm just tracking this. So what happens? What is the difference? What is the difference that comes in the accuracy? And I'm also saving that model. So once I find the best model, I can use that. Okay, so now we can see there are 2 runs. This is the first one and this is the second one. Okay, just try this. Okay, done all of you? So I hope you have done that. So you can just try changing the parameters. Okay, I'm just making the parameter maximum iteration as 3, and I'll just run it again. So updated code is, let me see, updated code is there. So I'll just put a comment, updated code. Okay, just try that. Updated code. The last cell in the collab file I shared. So you can see here my accuracy has dropped. When I changed maximum iteration to 3, my accuracy, which was 1 earlier, has dropped. Okay. So the reason being I changed the parameter. So you can see I have run 3 times. So 3 different folders has been created, each having the corresponding model and the data. So since my data doesn't have any change, that doesn't matter, but each has a model. So I can choose whichever model I want.
Hello, ma'am.
Yes, ma'am.
Ma'am, some doubts. Actually, here you have used one file named requirement.txt. Okay.
Yes.
Is this built-in one with some
No, no, no.
predefined? No.
No. I just defined it. I gave you the contents through chat, if you remember.
Okay. That
Okay,
means
so
we can create as
we
our
can
own.
create. Yes, we can create a file called requirement.txt or any name.txt. We can put all the libraries which we need to install. You need not install pip install pandas, pip install scikit-learn like that. You need not do it separately. You can just put everything inside this requirement.txt, and you can just type here pip install -r and that just give the file name. If it is requirement.txt, just give that, everything will be installed.
Okay, ma'am. And the second one is you have created one model by using logistic regression. Okay.
Right. Yes.
Actually, only one model you have created.
I just created a single model with logistic regression. Now I am trying with various parameters. I'm just changing.
Okay. That means when we use different parameters, this may create different versions, right?
Correct.
Okay.
So I'm just trying to keep track of these various iterations, various experiments, each we're having a different parameter value.
Okay, ma'am. Right.
Okay. Okay, so I hope you are able to do the same thing as I did. If you have if you're stuck somewhere, please let me know. Okay. So now I have 3 experiments to track. So I have tracked 3 experiments, out of which in two of them gave me accuracy 1 and 1 gave me accuracy 0.66, right? So let me just I want to see this as a visualization. I see it as a visualization. It will be more useful for me like that. So let me try using a visualization. So I am doing MLflow space UI. MLflow space UI. I will put it in chat as well. MLflow space UI. So if you click on that, it will run and create a UI file for you. Okay, it will create a user interface. Okay, it will take some time. And here, inside here, you can see a link, HTTP 127.0.0.1. Earlier, what we got for Flask, the same link, similar one, we can get it. So if you click on that, just click on that, you will be forwarded to a page like this, MLflow page. So all of you can you please just listen here. So this is the page for MLflow, which has tracked our experiments. So you can see it is a local host page. This 127.0.0.1:5000. So it's a local page. So, but we can see our experiment here. Okay. So just clicking on experiments, you can just see default inside default. If you remember, I did 4 experiments actually. Okay. Initially also I did something. So these 4 experiments are listed here. So the latest one 5 minutes ago, 9 minutes ago, 10 minutes and 17 minutes ago. It says how much duration it took. So first one was easy. It took 68 milliseconds, then 251 milliseconds, 298, and finally 384 milliseconds to complete. Okay. So it also show me how my models performed. Here you can see initially, the initial 2 models gave me an accuracy of 1. And the final model gave me the accuracy of 0.66, right? I can see it as a table. So here, if you want, you can see it as a, yes.
Please repeat, ma'am, this one.
This one, okay. Yes. Did you see in the chat MLflow or MLflow UI?
I executed that one.
Yes, and did you get a link there?
Yeah. I pasted there, but this run option is not there.
Sorry?
Here now you are having runs, model and traces.
Okay.
So I'm not getting these runs.
Okay, you are seeing an empty page like this?
No. That's why I'm saying, please repeat. Can you repeat it?
Okay. So are you able to see anything here in this page? Did you get this MLflow and all?
Yeah. Inside that home experiment model prompts AI gateway.
Yeah. Just click on experiments.
Okay. Yes, clicked.
Clicked on experiments.
Yes.
And did you see a default like this?
Yeah.
Click on that.
Okay. Yes.
Okay. Now you got? Yes.
Yeah, got it. Thank you.
Yes. Okay, fine. So you can see the various models I used. You can see the traces. Okay. So here in runs itself, if you want to compare 2 models, you can just click on 2 models and you can click on compare. Okay. And you can see the comparison of these 2 models. So these 2 models, how much time, what is the start time, end time, what is the duration it took, what are the parameters, very important. Okay, very important. So in experiments, I used maximum iteration as 300, 42, 42.2. So these are the same models, I think. Let me take 2 different models. Okay. So let me take this one first model and so let me just compare. Okay, so here clearly you can see here. Okay, so you can see here one of the model gave me accuracy 1 while the other one gave me accuracy 0.66. Okay, so maximum iteration was 300 for first model, the other one was nearly 200. So you can clearly see what are the differences. So maximum iteration in first case is 300, second case it is 200, which clearly deteriorated the accuracy, right? And the parameters, okay. The metrics, so accuracy is 0.67 here. Here the accuracy is 1. You can see what all artifacts has been saved here. You can see for every experiment, I created a iris.csv. We can compare that also. The data is same. In our case, the data is same. Model.pickle, we will not be able to preview that file. And you can see if there are any tags associated, they will show that. Okay. So here you can have a clear comparison, especially when you are doing multiple experiments. Here you can clearly put this when you are doing some research in your research papers and all, you can clearly show why this one model is better than other using these visualizations. Here you can add more metrics. If you want, you can add more metrics. Like we used only accuracy. If you want to see precision, recall, F1 score, everything you can track using this. And I only used one parameter. I used only this max iteration parameter. If you want more parameters, you can just add random state. But in this case, random state in both model, it used both of them used random state as 42. So that it meets here. So there is no much difference. So max iteration, there is difference. One used 200 and another used 300. Corresponding accuracy is 0.667 and the corresponding accuracy here is 1. Okay. Yes. So this is the way in which we can track our experiments. So if we want, you can just run more iterations of the same thing and understand what is the difference between each and every iteration. Okay, so basically what happens here is we are just, so I can log more artifacts. If you are building a deep learning model, you know, there may be various artifacts like the deep learning, the network that we used in deep learning model, the model that we built, like there will be multiple layers. If it is as sir asked me earlier, even if it is a CNN model, in that case, all you can just store all those artifacts here. So store all those things as artifacts. The only thing is you should start with MLflow and you should log all these things, which all parameters you want to change, log all parameters, build the model here, fit the model here, find the accuracy or whatever metrics you want and log everything. And it will show you as various different experiments here and it will be stored. The beauty is that everything will be stored once. If you want to use this model, you can just easily get it here. If you wanted to use a different model, you can get it here like that. So this is how you keep track of your experiments. So if it is clear for all of you, otherwise, if you have any questions in this, I am happy to help you. If you're clear with this, we can move to the next part of today's session, the JIT and DVC. Or if you want me to explain any part, yes.
Ma'am,
Yes.
I have one doubt. Suppose we are having a reinforcement learning model, for example, A to C, active critic model.
Okay.
Okay, in that case, we are having two networks in that reinforcement learning.
Yes.
So is it applicable for this one also?
For anything, see, any experiment, it is applicable. If you have two networks, you have to store both the networks inside this. You have to log the parameters of both the networks and you have to train both the networks inside here itself. This can be done on any machine learning model.
Okay.
Only thing is you have to log everything. Then it will be easy for you to understand what all changes. And also, this can be automated. So tomorrow you will see how to automate this.
Okay.
This can be automated. So you need not come and run it every time. You can just schedule. So today you want to try with 100 parameters, you can do that. Finally, you just, in the evening, you just come and see the MLflow visualization. Tomorrow you can automate it again to do another 100 experiments. So that's the main use of this. You can just understand. So since this is a very small example, it looks very easy. I'm just changing one parameter, but you know how a machine learning model works, right? In a machine learning model, you know, there are hundreds of parameters, hundreds of values, features, all these things. If you want to keep track of, we can use ML. So think about an industry, a machine learning model being created in a industry application. So this is very this the way in which it will be treated. Okay, so if that part is clear, we will move on to the second part of this segment, the version controlling part. So this data code, I'm having this code with me. I'm going to store it in GitHub, and whenever there is a change in the version, I'm going to change it using GitHub, as well as I will store this data in DBC. Right. Okay, so I hope all of you have GitHub account. If you don't have GitHub account, you can just start one GitHub account. Also, by the meantime, you can download Git. Okay, so I'll just show you how to do that. So you can just download Git. So you can just install for Windows. You can use that. Just install it. And if you have a Git, if you don't have a GitHub account, you can just start. And if you don't have any of these, I would suggest that you just listen to this and you can try it. Just note it down and try it. Others, because we are running out of time, like last 20 minutes. So I think I will be much more faster, because this is very easy. For those who are familiar with GitHub, it is very easy. But for those who are not, I'm just explaining it. So you can just note it down. And you will get the recording as well, right? So at that time, you can just repeat the process. Just see what we are trying to do. So I would just show you how these things are to be done. Okay. So as you know, GitHub, we can create repositories. So for this purpose, I'm creating a new repository. So I'm giving a repository name MLOps FD. Okay. If you want, you can give it some description, MLOps demo. So I want to choose the visibility, whether it is public or private. So I'm choosing it to be public, so that anybody with the link can see what is inside my repository. If you want, you can add a README file, license, etc. So here I'm not creating any of those. I'm just creating a repository. Okay. So this is the repository that I created. So once you install Git, you can take, again, as we took CMD from the folder, you can take it once more. From the folder in the address tab, you can just type CMD. So I just took the CMD, and if your Git is properly installed, if you type Git version, you can see the Git version in your system. And can just, in my case, it's already configured, but if you're doing it for the first time, you can do Git config global user dot name You can give the username. So where do you get the username? In GitHub. If you see here, in the GitHub folder, if you see here, you can see your username here. Okay. So you can just copy this and can just similarly, you need to configure the email ID as well. The same email ID you used to create your JIT account. Okay, so I have configured my JIT account and I can just install DVC. So I will share a detailed document with this, with the steps. So if you are not able to complete along with me, you can just refer that. Okay. So DVC was also installed. So you can just check the version. DVC is installed correctly. It will show you the version. Okay, done. So next thing we'll be doing is JIT init to initialize the JIT. So now there is an empty repository. We have not added anything. So we want to we need to first create a remote address. So in our case, so here you can, so since we created a repository, you can click on this HTTPS and you can just copy this. I'm going to, in this remote repository, I'm going to add all my code. Here now the repository is empty. So we are going to add our code. So for that, so here you should type JIT. Okay. remote add origin, clipping that we paste. So now I have added the origin as the new repository I created, MLOps FDP. And I'm going to create a branch here. So each branch is used to track the changes in my code. Okay. So these are few concepts of GitHub. We will have various branches. If multiple persons are working on same project, they will have various branches. So like that. So for now, just consider we are just going to create. Okay, so I'm going to do git status. Just find out the git status. So you can see when I do git status, all these files are in red color. That is the files which I created, app.py, iris.csv, MLflow, all these files are in red color, including, it says that these are not added to GitHub, right? So we need to add these. So for that, I will just do git.add dot, which indicates add all the files. Okay. Git.
Ma'am, hello.
Yes.
Ma'am, that git remote origin is not working.
What is the problem? Can you tell me?
It is saying that error unknown subcommand origin.
Is your git this one git remote? Have you written it correctly? Git remote add origin.
Wait,
Just check.
Git remote add. Yes, I think I missed that add word.
Yeah, that may be the reason.
Okay, now from there you can explain.
Okay, so after that, I will just put all these things in chat. Okay, whatever things I did after that. So I did git -m main, and then I checked git status. And then I added everything, git add dot. And now again, I am just checking the status. So you can see now everything has changed to green color, indicating everything has been added to the local git. All these things are added to the local git. So to complete this, to commit this, if you want it to reflect in your GitHub account, you need git commit. So commit is done once you are finalized. You have every change is done.
Git add is not working. Nothing specified, nothing added.
Git add, after that you should put a dot. Here there is a dot. Done?
No, ma'am, no.
Okay. Are you in the same folder?
Add space again dot. Now space is there.
Git add space dot.
Yes. Then next.
Next, just check the status. You can see everything in green color. Earlier, everything was in red color. These were not added in your git. Now, when you see the status, everything is. Now we are going to push this into our original repository. You can see my repository is empty now. So I will just push everything to my repository. And also I will just say this is my say version 1 with data set. Okay, so everything has moved to my. So you can, this is just, I just gave a simple comment for me to understand. You can give anything there. Okay, that is not specific. You can give anything. The only thing you need to do is git commit -m. Now let us see my repository. Okay, let's see my repository. So I'm just refreshing my repository. And let me see if it has been added. Okay, it has not been added. Let me just check.
Ma'am, did you do git push?
No, I didn't do the git push. Sorry. Yeah, that step I missed. Yes, so you have to do this because earlier when I tried that, I got an error because I didn't create the branch. Okay, so now you have to do this as well. I have put in chat. And after that, you have to come.
Okay, ma'am.
Thank you. Okay, so let's now try to see our repository. You can see everything has been added to my repository. All the things along with the runs. It's been added to the repository.
Ma'am, this MLflow also using this versioning, right?
Yes. MLflow, that is like, actually in real case, we need not add all these MLflow things. MLflow like folders you can avoid when you upload to JIT.
Okay.
Once you finalize the model, you just need to upload the final model to JIT.
Okay.
And let us do the DVC part as well. So you can just make a small change in the data and we can just okay, so you can just do so you can just do DVC in it. The same thing. It's the same thing. You have to just okay, so DVC in it. Now I will just create a directory called data here. And if you remember, we had a code where we saved the data. If you go to that folder and see, now iris.csv is there, right? So we can just add, if you want, you can add to this data, or you can just directly give DVC add iris.csv. If you want, you can put it in a directory called data, and then you can add it to DBC. Otherwise, also just fine. So in our case, it is already there in JIT. That is the reason. So maybe we can put it inside data. So you can just copy it inside data and try. Okay, now it has added. So I put it inside a folder called data and I tried. So now it has added it. So that data will be in a .dvc file in our GitHub. So this is how we keep track of data as well as code. So versioning part is done. So this is, as I told, we can build models, we can create models, we can just create very good models with very good results. But if you follow this process, so you may ask, I have created a lot of models without MLflow, without GitHub, or yes, you can do that. But this is like what we told earlier. If you want to reproduce the result, if you want the same taste for your cake, it is better if you can version it and keep it, so that even after 2 years, 3 years, you can reproduce the same result. Okay. So with that note,
Excuse me, ma'am.
Yes, Parul. Yes.
Hi, yes. Will you share the complete documentation of the
Sure.
gift part?
Sure. I'll be sharing. So maybe after the 3 days of session, we'll just share a complete note. Okay.
Okay, thank you.
Because tomorrow and day after tomorrow also you are having sessions from ICT. So I will share mine, and we can consolidate everything and we'll share it.
Okay, thank you.
Okay.
Ma'am, will we get this recorded session also?
That you have to talk with your FTP coordinator.
Sure.
I'm not sure about the policies they have.
Oh, okay, ma'am. No problem.
Anyway, I will give you a detailed note on all these things, which all commands I used, what all things we did. The code is already with you. That notebook is already shared with you. So all other commands like JIT commands, DVC commands, all those things I can share.
Thank you, ma'am. Thank you so much.
So now we have just 1 more minute left. Maybe I can take 1 or 2 questions if you have any. I hope the session was useful for you. So please, from now on, track your experiments and see the difference that it makes. Because when you work, especially when you do research, we do many things. We experiment with many models on a typical day. So after a few days, we may not be able to remember what result we got. We may tell, okay, last time I got a better result, but I don't remember what are the parameters I used. So if you keep track of that using MLflow, it will be very easy for you to understand. So please try to use that. Also GitHub, I know you are all familiar with GitHub and DVC. So with these process, your task will be more easy and reproducible. So do we have any question? Anything?
Hello, ma'am.
Yes.
Please tell us actually what is the main difference between one algorithm and one model. Algorithm and a model.
Okay, fine. So we have various algorithms to implement a machine learning model, to create a model. So as I told earlier, we have different kind of machine learning algorithms like supervised learning, unsupervised learning, regression, classification, like that you may have heard in high level. Okay, so we have the way in which a machine can learn depends on the algorithm. Okay, as you change the algorithm, the way in which machine learn changes. That is the purpose of algorithm. When I tell a model is built using the data that you give. So once, if you want to build a AI camera, you will give some images, you will give some labels, and you create a model. That is the model that you create, and you will be reusing that model for example, Kerala police have created a model, and they are using that model to identify whether people with helmet and without helmet. How that model gets built, we don't know. Maybe they have used CNN algorithm. Maybe they have used some pre-trained model like RSNet. Like that, there are multiple algorithms that can be used. But the model that they created, we are seeing it right now. They are using it right now with all those data. So I can use CNN algorithm to identify cat and dog. I can use a CNN algorithm to build a model that will differentiate between cat and dog. I can use CNN algorithm to build a model that can identify people with helmet and not without helmet. Is that clear now?
Yes, ma'am. Yes, ma'am. Thank you.